Hi, my name is Matthew Mason. I am a Director of Maintenance for a corporate fleet of aircraft for a Fortune 500 company. I've been doing aircraft maintenance for 30 years at this point, or near it, and I'm here to talk a little bit about aviation and the history. I was in high school and in a group that got exposed to a salesperson for an airframe and power plant school, and they introduced that to me. I never had the idea or concept of airplanes requiring any kind of maintenance or working on them or anything. I enjoyed working on things, but I didn't want to be a car mechanic. So I was interested. I did it. I looked into it, and having not been a student at all in high school, I learned that I was very interested in aviation maintenance, and I actually became a student in that two-year school. And that is how I was exposed to aviation for the first time, and I spent the rest of the 30 years since then performing aircraft maintenance.
My name is Jeff Good, and I grew up in the Midwest, so I grew up in the state of Indiana. Been flying airplanes now for about 28 years. Started off, I've actually got experience in the corporate aviation world, the airline industry, as long as the charter industry. My interest occurred really in first grade. We had a first grade field trip that we'd taken a trip to the airport. And anyway, so that sparked my interest in airplanes, and I thought that's what I want to do. So we fast forward, I'm 16, summertime, taking my first lesson, and I wasn't necessarily sold on the idea of flying airplanes, but it piqued my interest enough to say, I think I want to go back. So fast forward now, almost 9,200 hours later, here I am as a full-time professional pilot.
So powered flight begins obviously with the Wright brothers as being the first successful aircraft that was ever produced. There are other aircraft manufacturers that are claimed to be first powered, but they didn't actually fly an aircraft with an engine in any length of time, any distance. They wanted to go further than just gliding, which is where the idea of powering the aircraft came. So while they built the glider, and while they knew how to do that really well, they did not know how to build an engine. So they contracted with their bicycle mechanic, Charles Taylor, and he produced their engine in a record period of time with a weight to power ratio that had never been produced before. Every engine that had been an internal combustion or external combustion, which that aircraft was, that engine was too heavy and too big. And he produced it in a short period of time, and it produced more horsepower than they anticipated or wanted or needed at the time. But it became the key to powered flight. An interesting portion of that is that the propellers that they used and designed were obviously a new concept, but the engineering that they put behind that propeller, that design over history, even to today, has not been able to be produced better. The ratios, the curvatures, the airfoil itself, that science, that engineering that they did has still not been able to be improved upon. Airplanes really started out as an experiment, and it was a can we do it? That was the Wright brothers. They went to Kitty Hawk, and their mission was to see if they could do it, see if they could fly. That mentality stayed through aviation up through World War I, World War II, and the production of airplanes was more about, can we do it? Can we create an aircraft with a mission purpose to bomb or destroy things. And so aviation was very much a trial by error, trial by fire, and a let's see if we can do it type of industry, especially during the war years, because there was no other purpose to build the airplane than to win the war. And so they did all kinds of different things, all kinds of different designs. They tried all kinds of different things that they wouldn't have had the funding to try if they were just doing it from commercial market. So the advancements in aviation and what rolled into automotive really started in World War II with a lot of the airplane builds and all the airplane designs.
So we've come so far. I mean, you literally look at the Wright brothers to what we have now. I mean, the whole aerospace industry, where you've got launching airplanes into the atmosphere, and we're trying to reach Mars and all that stuff.
The world of aviation has changed so dramatically since the Wright brothers. We have aircraft now that can fly for 14 hours without being refueled and do 2 stops to get around the world. The biggest change in aviation is the onset of the jet engine and its ability to fly aircraft higher and more fuel efficient than reciprocating engines that the Wright brothers used or any small aircraft used. The evolution of the jet engine without having propellers and all of that push the aircraft through the air has given the ability to produce power and lift aircraft that are 600,000 pounds. A 747 is 600,000 pounds fully fueled. There's 300,000 pounds of airplane there and 300,000 pounds of fuel, and that 4 engines can lift that aircraft and propel it through the air for 10 to 12 hours, which is an incredible feat. Some of the lessons learned through the years have all been around safety since the Wright brothers. I mean, it's no secret that they crashed several of their airplanes. The first landings were controlled crashes. After that, they had some real crashes and injuries, and we continue to have those. And through the years, safety has been the #1 advancement in aviation.
I would say really the manufacturing too, the way the manufacturers build airplanes, from the efficiency, pieces and parts are just manufactured really well today. So safety has really gone from a really high level nowadays from what we're doing. The amount of airplanes that we're packing into a certain airspace has gotten, the requirements have gotten more stringent, but yet it's more efficient though, and it is also safer too, just because of how we position the airplanes and how we know where the airplanes are at from the satellites and from the air traffic controllers. So every day we face a risk, right? I mean, you walk down a flight of stairs, you face a risk, you might fall down. But we have those same type of risk when it comes to aviation too. We're looking at how the condition of the airplane, the mechanical condition, right? So we're looking at the weather conditions. Is it a beautiful day like it is today, or is there snow coming down? Do we have a blizzard? So we look at a lot of risk factors and what we assume what is an acceptable risk and what is a non-acceptable risk. So in other words, how do we mitigate the risk? And that's a big thing in aviation nowadays, is how do we mitigate the risk?
A lot of aircraft designs, because they were mission purposed for war or for cargo or for pleasure, they had failures that created crashes and accidents. One of the things that we've had happen over the years is fatigue, and aluminum, which aircraft are made out of because it's very light, it gets stress cracks over time because of movement. The aircraft flexes and moves, and it becomes, those areas where they move become stress risers, and so the cracks develop, and then the aircraft tends to, in the past, come apart in those spaces, and that created accidents and crashes. So design features come out to create more resilient metals, more resilient components, more robust parts, more robust engineering designs to keep those cracks, to keep those fatigue issues from creating airplanes that have inherent issues that cause accidents. Other safety measures have been all about the cockpit and the avionics of today.
You look at, I don't know if you've ever seen a radar imaging map. Like you can go to like there's an airplane tracker, and the whole like United States is covered. You're like, how many thousands of airplanes not hit each other? Really, back in the day, we used to have what was called AM radio towers, and we could literally fly from an AM radio tower to another AM radio tower to another AM radio tower. Now, if you can imagine, none of those are in a straight line, which is really the best way to get from point A to point B. So we would do a lot of jogs left and right. So nowadays, everything is all GPS based. So we have all space-based navigation, where we essentially beam our signal up to some satellites, they beam it back to a radio tower, and then that gets sent to what we call an air traffic controller. So we have a very accurate way of navigating today. So that's been a big leap when it comes to the aviation industry.
One of the systems that we have in the aircraft alerts the pilots when they are approaching a runway, tells them what taxiway they're on, tells them what runway they're approaching, tells them what runway they're on when they actually come onto that runway. The reason for that is we've had pilots in the distractions of weather and other mechanical issues or problems or even just crew member interaction. There's a lack of situational awareness at times that has actually allowed the pilots to take off on the wrong runway. So this technology is needed to keep everybody situationally aware of where they are, and even with that, we still have runway incursions, and we have taxiing on incorrect taxiways, taxiing on runways, trying to take off on taxiways instead of runways. Having those safety features baked in has prevented a lot of accidents. We have ground proximity warning systems now that tell the crew that's flying the airplane how close they are to the ground, and if there is a ground obstacle for them to be concerned about in fog and things like that, where you can't see the ground and the ground is rising up under you because the elevation is changing, but your altitude is not changing. The ground can become an obstacle, and there are systems to warn of that. We have systems called TCAS, which is traffic collision avoidance systems. Now the airplanes can see other airplanes, and we can have those avionics not just say that there's an airplane in their path or near them, but it actually creates a resolution for them to fly out of that path situation so that they can prevent in-air crashes. And yet with all those things, we still see that happening. Distractions are a big issue in aviation. It's caused many, many accidents. So anything we can remove distractions, increase situational awareness, decrease workload for the crew, makes the aircraft and the aviation industry safer.
I think anybody that can take flight, that's a huge leap for a lot of people. To be able to see the atmosphere, to see the sunrises and sunset, the moon coming up. You know, I've flown south of Mount Rushmore. I've flown south of Mount Everest. I've been over the middle of the Atlantic, been over the middle of the Pacific. So just to see literally how small you are in the space of the planet Earth really is something to kind of grasp and think about. So, but the fact that you get to experience it I think is really just is really fun. I've seen some amazing sunsets and sunrises. A lot of people don't get to see what I've seen. I've seen some star-studded nights that will just blow you away. When you get away from all the white noise around the earth and the ground, and you get up there where there's really not a whole lot of light, you see some amazing, amazing stars. A lot of shooting stars, a lot of beautiful moonrises, and a lot of beautiful sunrises and sunsets. And sometimes I've seen some thunderstorms at nighttime that will just light up the atmosphere. You can point to the Creator. It's like a Bob Ross moment every time you fly.
Oh, I have slipped the surly bonds of earth, and danced the skies on laughter-silvered wings. Sunward I've climbed and joined the tumbling mirth of sun-split clouds, and done 100 things you have not dreamed of, wheeled and soared and swung. High in the sunlit silence, hovering there, I've chased the shouting wind along and flung my eager craft through footless halls of air. Up, up the long, delirious, burning blue, I've topped the wind-swept heights with easy grace, where never lark or even eagle flew. And while with silent lifting mind I've trod the high, unpassed sanctity of space, put out my hand and touched the face of God.